Calculus 210, and today we're going to talk about the derivative of the rest of the trig functions. So tangent, cosecant, secant, and cotangent. I've got the derivatives up here. Remember, d over dx means the derivative of sine u equals u prime cosine u. So I've written the 6 trig functions here for you. Remember, we already done sine and cosine. We've been practicing those for a little while now. So we're going to learn the other 4 today. So before we go further, go ahead, copy these in your notes, pause the video, get those down, and then you'll have those to refer to as I do examples. Just remember that whenever you have the derivative of a trig function, your trig function is going to have an angle part here. It will usually be some sort of a function. Sometimes it'll just be a variable, but usually it's going to be a monomial or a binomial, or even, it could even be a trinomial or some kind of a function. So you need to make sure that when you take the derivative of a trig function, you're taking the derivative of that angle part first, and then taking the derivative of the actual trig function. So the derivative of sine u would be u prime times cosine u, because the derivative of sine is cosine. Okay? The angle part has to stay with the trig function after you have taken the derivative. If you forget that, you're going to get them all wrong. So make sure that that angle part that you have there, whatever it is, stays with the function, and the derivative of that angle part is going to be multiplied by the derivative of the trig function. Remember, the derivative of cosine u was the opposite, or negative, u prime sine u. So the derivative of cosine is a negative sign. Okay? The derivative of tangent. Remember, we did that in the last section when we had that application where we were doing the quotient rule, and I asked you to find the equation of the tangent line. And remember, we rewrote it as sine over cosine and found it using the quotient rule. But what you need to do now is just memorize this. You don't want to have to redo that math every time you see a tangent function, because it's always going to be the same. The derivative of tangent u is u prime secant squared u. Okay? The derivative of cosecant u, now remember, cosecant is the inverse of sine. A lot of students get that mixed up. They think it's the inverse of cosine, but it's not. It's the inverse of sine. Okay? So derivative of cosecant u is negative u prime cosecant u cotangent u. The inverse of cosine is secant u, so the derivative of secant u is u prime secant u tangent u. And then the derivative of cotangent u is the negative opposite of u prime cosecant squared u. Now, one thing I always point out to my students when I'm showing them these, you do have to memorize them. There's just no way around it. It's going to show up so much, it's going to help you to memorize them. So go ahead, start committing those to memory today. You're going to use them pretty much every day for the rest of your calculus experience. So you just need to know them. Make sure that you remember. The most common mistake is forgetting the negative signs. So what I always tell my students is any trig function that starts with a c has a negative derivative. See that? Any one that starts with a c has a negative derivative. If you can remember that, you'll be able to remember which ones are negative and which ones are positive. Okay? So if they start with a c, if the original trig function starts with a c, its derivative is negative. Okay? So that's what you need to memorize. Let's do some examples. Here I've got 4 examples using trig functions, and your directions are going to be to find the derivative of the trig function. For this one, remember, if we have a constant in front of the function that we're going to find the derivative of, that constant just comes down as part of the derivative. So if they want us to find the derivative of 5 sine 2x squared, f prime, I'm going to bring down the 5, and then I'm going to take the derivative of the trig function. Well, we know that the derivative of sine is cosine. We keep the angle part, and then we take the derivative of the angle part, so that's 4x. And then we will multiply those together. So f prime of x is equal to 20x cosine of 2x. That is all I can do there for the derivative of that function. F of x equals tangent x squared. For this one, for f prime of x, the derivative of tangent is secant squared. We keep the angle. Then we take the derivative of the angle. That's all we can do for that one. So they're really pretty simple if you have them memorized. As long as you remember what the derivative of the trig function is and remember to take the derivative of the angle part, and any constant you have in front stays with it, it's pretty simple. For this one, f of x equals cosecant of 3x cubed minus 6x squared. Well, this is cosecant, so I know it starts with a c, it's going to be negative. I tend to do that right off the bat so I don't forget to put the negative down. So I know it's going to be a negative. The derivative of cosecant is cosecant cotangent. So that would be cosecant, we keep the angle part, cotangent, and again, we keep that angle part. We do not get rid of the 3x cubed plus 6x. We don't get rid of that. We keep that angle part with the original, or with the derivative of that original function. And then we have to multiply by, now this was your u, 3x cubed plus 6x. So then in the front, we have to have the derivative of the u part. So that would be 9x squared plus 6. I then put it in parentheses. Now, you could distribute that negative sign among those. I would just leave it like this. A lot of times if they ask you to do an application, you're going to plug something in for x, and a lot of times it's easier to just leave it separated like that. If I could combine anything, I would. A common mistake is people might look at this and say, oh, I could bring out a 3 from everything. No, you really can't. Well, I mean, I guess you could bring a 3 out of this and put it in front, but that's really not going to help you with anything. It's just as easy to leave it there. Okay, for this one. Sometimes it's going to be necessary to rewrite your function before you take the derivative because it'll make it easier. And if you look at this one, now we could use the quotient rule here if we wanted to. We'd still get the same answer, but that might make it more difficult than just separating that fraction out. So one of the things with calculus, one of the algebra things that you need to realize is sometimes when we have a fraction like this, we can separate that fraction into two separate fractions and then just do the derivative of each separate part. So 1 over sine, I can separate that out, 1 over sine x minus cosine x over sine x. Now if you look at what we've really got there, isn't our function 1 over sine is cosecant and cosine over sine is cotangent. So isn't it easier probably, rather than doing the quotient rule and having a lot of work to do, to just take the derivative of each of these separately? So that's a little bit simpler than trying to do the quotient rule. So if we do y prime, the derivative of cosecant is negative cosecant x cotangent x. Remember, we keep the angle part. The derivative of x is just 1, so that's the first term, the derivative of it. And then we've got the minus. The derivative of cotangent is negative cosecant squared x. So the negative is going to make this a positive, and we have cosecant squared x. The derivative of x is 1. So that is all that we need to do there. Now, you could distribute out the cosecant x and have cosecant x, and you could even distribute out a negative cosecant x and have negative cosecant x, and then in parentheses, cotangent x plus cosecant x. That would be fine, but there's no need to do that. Unless they ask you to do something else with this and do an application with this, there's really no need to do anything else. Notice we've got a product rule here plus another function. So if I take the derivative of that, I can't ignore that I've got a product rule here. To get the derivative of that first part, I'm going to have to use the product rule. So if I use the product rule, the derivative of the first thing is 1 times the original second thing, sine x, plus the original first, x, times the derivative of sine is cosine x. Now the derivative of x is just 1, so we don't need to put anything else there. And then we're going to add to that the derivative of cosine. Well, the derivative of cosine is negative sine, so instead of a plus, that's going to be a minus sine. And then if you look at what you've got there, don't the sine x and minus sine x cancel out? So that will just leave us with f prime of x equals x cosine of x. And that's all you can do there. For the next one, if you look at this, that's also a product rule. If you look at what you've got, this is the first term, and this is the, well, not really term, but this is the first thing and this is the second thing. So you've got two things. This is your u and your v, right? So if we're using the product rule, so the derivative of the first thing, the derivative of cosine is a negative sine, keep the angle, x squared, and then the derivative of the angle is 2x, times the original second, which is sine x squared, plus the original first, cosine x squared, times the derivative of the second. Derivative of sine is cosine of x squared. The derivative of the angle part is 2x. Then I can combine some of this stuff. So I've got negative 2x sine squared x squared plus 2x cosine squared x squared. Here's an application of taking the derivative of a trig function. They're giving you f of x equals 2 plus 3 cosine t, and then they want you to find f prime of pi. So they basically want you to find the slope of the tangent line for f prime at pi, or the slope of the tangent line of f at x equals pi. So if you take the derivative, f prime of x, well, the derivative of 2 is 0, so we leave that out. The derivative of 3 cosine t, we keep the 3. Derivative of cosine is negative sine t. And then if we want f prime of pi, we will plug pi into that, negative 3 sine of pi. And then if you look at a unit circle, just draw a real simple one here. At pi, that ordered pair is negative 1, 0. So sine at pi is 0. So negative 3 times 0 would be 0. So the derivative at f prime when x is pi is 0. So at that spot, we have a horizontal tangent line. If you think about that, the sine function, doesn't it look something like this? Well, what that means is that x or that pi value is either here or here, the horizontal tangent line, or if the slope of the tangent line is 0, then pi is either at a peak or at a valley.